Howdy, folks. Hope everybody's doing well. Um, Today, we're going to talk about random number generation in this video. We're also going to talk a little bit about vectors and a list that can then change size. And so just a quick reminder before we get into it, how to use this video. So we'll watch the introduction where I start to introduce some topics. And then when we get to like an actual problem to check out, that's where we're going to hit the pause button. And then you're going to take time to actually work through that sort of puzzle problem. And the goal is that, you should either like get it solved or, spend, 15 minutes like really working on it. And then if you get kind of stuck, then that's going to be time to unpause the video. And then you can, see how I ended up approaching it. And that's sort of the plan. So let's switch over to the code here. And I want to show you a block of code here. So there's a few things going on. Before we unpack this too much, I just want to talk about, remind us a couple of things. So one, C++, likes to have us specifically include things that we want to use. And if we don't include those things, then we're not going to have access to them. So in this case, we're going to have two new includes that we're going to use when we want to do random numbers. One is the time library, and that's going to let us use the time that the programs run to help us do some stuff. And then the second one is this random library. And the random library is actually pretty important in that, C++, again, lots of different uses, lots of different ways people are using it. But people are actually pretty particular about how they generate random numbers. For instance, when I was designing slot machines, how we generated random numbers was actually really, really important. There were a couple of reasons for it. One, we didn't want anybody to be able to cheat. Right? That was like a hugely important thing. But also we needed ways to know which patterns of random numbers we were generating. And that had to maybe do with compliance. We had to prove that we weren't cheating when we designed those things. Or we needed to be able to adjust them in certain ways to adjust how the slot machines, for instance, performed to make them sort of pay out more or less money. So there's all sorts of reasons that we might really care about a random number generation. And so this random library actually has a lot of different algorithms in it that generate what we call pseudo random number generation. So turns out if we use an algorithm on a computer, there's no way to get pure true random numbers. And actually that's kind of one of those things. Is there actually any way to purely generate random numbers? It's a little bit of a philosophical debate. So, but to be technical, we say pseudo random number generation. And so let's kind of talk about how it works. So the reason that we want this is that we want to be able to pick which random number generation, and we're going to use this one, the MT19937, which sounds kind of crazy, but actually it stands for the Mersenne prime twister, which is the algorithm that it's using to generate numbers. And basically the idea is it's very hard to predict what the Mersenne prime twister is going to do, and the pattern doesn't repeat very often. So if you think about how a lot of these things work, if I was going to generate 100 million numbers, I wouldn't want them to wrap around, right? So I kept on getting the same 100 million numbers. So the idea is that the pattern that you generate from this should be quite long, so you don't get that. So anyways, so what we're going to do is we're going to set up the generator kind of here at the top. And this is just going to let us use this generator in any functions that we make. In general, we try to avoid making functions up here, or variables up here, and we just, kind of define our functions and whatnot. But we'll add this in here. And so what this is going to do is this is going to be sort of like the thing that generates our listed numbers. So don't have to really think too much about anything other than just including this line. This little time.null thing basically says when I run my program, grab the time it is, and we're going to use that to sort of prime the pump so that we get different numbers every time. This is actually really important because I was saying before, like you might want to reproduce this. Like let's say I wanted to make it so that I was doing a scientific experiment and I wanted to generate random numbers, and then I got a very exciting result and I want somebody else to confirm my result. I might say, you know what, I used random number sequence 22. Why don't you guys try that? And so then people might try it with 22, see what the behavior is, reproduce my results, and then they might try it with other specific random number generations to see if, you know, it's consistent. And so this lets us sort of like write down and keep track of that, which is great for when we're doing experiments. Time null is kind of maybe like what we might do more for a game. Hey, we want this to have some randomness and we want it to be different every time. Next thing we're going to do is we're going to pop into main. And this is kind of the really important one that we're going to use, because this is going to decide how our random number generators look, like what values they have, and the chance of getting each number. So what this says is it says uniform int distribution. And what that means is it means kind of like this. Like imagine you had like a die, and it had, in this case, it had 6 sides. So this is going to be, there's an equal chance of getting a 1, a 2, a 3, a 4, a 5, or a 6. And that's what the uniform thing. Every number has a chance to do it. Integer means int means integer, and distribution is that sort of pattern. So if we're gonna like draw it, you know, it would be like, you know, like a flat line. Everything has the same probability. Similarly, there is something called uniform, and you can see here that there's a uniform real distribution, which I'll pick. And then that is going to be type float. I'll call it float dist. And maybe for this one, we'll go, we'll just go between 0 and 1. So this is going to be the same thing, but real means I'm going to get, you know, small decimal values. So let's just generate 10 random numbers just to see what this looks like. I'll comment out the real one for now. So I just made a little for loop that goes 10 times. And then you can see this is how I generate it. It's really simple once I did it. I say the distribution that I want and then feed it the generator, which will actually pick something out of that distribution based on the algorithm. So if I run this real quick, you'll see that I got, you know, some numbers between 1 and 6. Sounds great. Let's run it again real quick. Hey, look, I got different numbers. Run it again. Hey, run it again. Looking great. So I'm getting like a different pattern of numbers. And then if I change this to float dist and I uncomment this line, okay, I'm going to run it. And you'll see that now I got a bunch of numbers between 0 and 1. And I can put whatever values in here, like, oh, I want between, you know, 0 and 10. I can give this a run. And you can see here now I have some decimal numbers. And we're, you know, to 5 decimal places here. Looks like, or I guess I should say 5 sig figs, because it looks like we have a few other ones in there. So anyways, so this is a great way to do it. We know we're going to get like truly random numbers. That's great. And again, the names of these can be whatever I want. You know, I could call this like cat distribution and then come down here and say cat distribution. And look, I got my integers back. Okay. So the big thing that I want to do with this is I just want to give it a name that I can use and then just make sure the values are set up. So it makes it really easy for me to just set up like, oh, I need to get numbers between 1 and 10, or, you know, negative, like we could do like -5 and +5, right? And so we run that and hey, look, we got some negative and positive numbers there. So really super helpful for generating exactly what we want. And then it has the added benefit of we know the algorithm, we know it's a trusted algorithm, and we're sort of thinking about it a little bit. So if you search up like on like C++ random numbers, you'll actually probably not find this way as the standard way. You'll find one that's a little bit different, but this one just works a little bit better. It gives us a wider range of numbers, and I think this is a great place to go. So let's head over to our first little program to do, which I call Rodem Bones. So this problem, you're going to be creating a simple dice rolling program. You're going to ask the user how many dice they would like to roll and how many sides their dice have. Send those values to a function which will roll the dice and return their sum. So, familiar if anybody's played a little D&D. Okay, I'm going to pause it up. Have fun working on this one. Okay, folks, hope you had fun working on that problem. So I'm going to come back and I'm going to switch over and I'm going to code up a version of this for you. So I'm going to just start off by my function because I know that I'm going to have a function and I know it's going to take in some inputs and it's going to send something back. So the thing that we said it's going to send back is it's going to return the sum. So that means the return type of my function is going to be an integer. Then I'm going to give it a name and I'm just going to call it Rodem-Bones. Okay, and then I am going to send in 2 integers into this thing, right? So we talked about one is how many dice they want to roll and how many sides they want to have. So I'm just going to immediately copy my prototype down to the bottom, and I am going to call this one num dice. And I'm going to call this one's sides on dice. Okay, just so I have some nice clear variables like that. Remember, I like to do variables that kind of make sense to me because I can use autocomplete, and so the typing out something long doesn't matter to me because I have that. So just like we did in the random number generation, this is where I have my generator made up here. And in my little function, I just need to call the right distribution. So I'm going to make a uniform int distribution, okay, use my autocomplete there. And I'm going to make sure that I send it type integer. And I'm going to call it, I don't know, I'll just call it int dist, why not? And then what are my ranges on this? Well, I'm basically going 1, 2, sides on dice. Okay, so that's going to give me a range on however many sides it is. Oh, it's a 20-sider. 1's always going to be my first number, and sides on dice is going to be my top number. Cool thing about this is that I'm going to be able to roll dice that aren't like ones that maybe you have like physically. Like I could roll a 7-sided dice, which I don't have one in my dice bag. So then what do I want to do? Well, I want to repeat this over and over again. I'm going to add up a sum. So I'm going to make a integer, which is going to be just my sum. And this is going to be the value that I send back to everybody at the end. So there's my sum. And then I'm just going to make a quick for loop. Okay, int I, starting at 0, I is less than the num dice. Okay, I plus plus. And so this is going to give me a chance to, well, what am I going to do? Well, I'm just going to add up the thing. Now, I'm going to do something here to start because I want to test if it works. So I'm going to make something called a roll, and then I'm going to do int dist, and I'm going to do generator. Okay, and so I'm sending it the generator, and I'm going to do my distribution. Okay, and then I'm going to see out my roll. And then I'm going to do sum plus equals my roll. And so why am I going to do that? The reason that I'm going to do that at the end here, I'm going to return my sum. So one, I want to make sure that I actually am returning a value that makes sense because I know that it's going to return a number. Okay. But if I don't print out what the rolls are, I don't know what it's going to be. Now, once I get this all tuned up and I trust it, then I'm going to get rid of this step and I'm going to clean this up a little bit. But for now, let's give it a thing where I'm going to see out. I want to see out whatever the rolled dem bones is, and I'm going to say, well, I want 3 dice and 6 sides. Okay, so now I got something I can run and sort of test out. So I'm going to run, and oops, I got 2, 3, 2, 7. Well, that's good because I got a 2, I got a 3, I got a 2, and those add up to 7. But it's a little hard to tell that because they were all sort of written together. So let's like do some end line, and maybe I should see out like, you know, total. Okay, so let's give that a roll. And you can see here that it printed out total 5, 5, 4, 4. Oh yeah, that's right. The C out statements are in the like thing. So printing out the total isn't great. My test case was a little bit wonky, but let's roll again and see if we're happy with it. So we can see that there's a 2, a 2, a 4, and an 8. And let's do that one more time. A 5, a 2, a 6, a 13. I'm feeling pretty good about that. Okay. So now I can get rid of all that C-outing stuff. And if I wanted to, I could actually just have, I could say, like, get rid of the step of saving it into a variable and then adding that. I could just plus equal into this generator, but I'll leave it like that. This makes it a little more readable. Okay, so now I have roll dem bones. Well, what's the next thing I need to do? Well, I need to, let's see. I need to make a couple of variables. So I'm going to do declare a couple of variables on the same line. And I can do it like this just to kind of save a little bit of space. And then I actually assign it a value, use a comma, assign it a value, and I can put more than one thing on each line. And so now I have the user sides and the user dice. And then I'm going to do cout. You know, please enter how many dice to roll. Awesome. And then that's going to be a cin user dice. Okay, cout. Please enter how many sides on each die. Okay. Awesome. Cin user sides. And then what am I going to do? Cout. Our total is, and it's going to be roll dem bones of user dice and user sides. Okay, and all things go, I can be like 5 dice, and you know what? There's 11-sided dice. And hey, my total is 31. Now, before I might have been like, oh my gosh, that was like really weird. Like 5 dice, there's 11 sides. I only ended up with 31. Like, didn't think, but I tested it before, so I feel pretty confident that's working right. And so there you go. That's our little solution to this. And this is something that you might end up doing, you know, other times where you make a little function to help you roll a certain number of dice because you don't want to, you know, like, oh, you know what, I'm going to have a little 20-sider, I'm going to have it. So you just don't have to, you know, keep track of various distributions. You just make functions that do it for you. Okay, hopefully that was helpful, and we'll head over to the next thing. Okay, so quick transition over to our next thing. So we're going to introduce this idea of the vector. And the vector is a dynamically sized list that we use in C++ fairly commonly. So let's just jump right into the code. If you jump over here, you'll notice that I have a brand new include called a vector. And basically a vector is going to work a lot like the list that you've seen, like what we did in Blackbird and things like that. It's going to have an ability to define it, and then you can make it kind of whatever size you want. So up here in my main, I'm just going to declare a vector, and then I put inside the little pointy brackets, just kind of like what we did with the random number generator, I put the type of thing that I want it to hold. So in this case, I want it to be an integer. And I'm just going to call this one numList. And so there you go. If I make this, now I have made a brand new like size 0 vector, which is great. And if I want to like put something into it, well, I can just do, as you might expect, I do numList dot, and then notice there's a bunch of secret words in here. When I start typing, I'm going to do push back. Okay. And in this case, I'm going to push back roll. And then I'm going to see out numList at spot 0. Okay. So if we give this a little bit of a run, okay, you'll see that it put 84 inside the list. Okay. And so that right there is pretty smooth. Just to kind of see this a little bit in action, well, let's just do a for loop. Int I equals, I don't know, 0. I is less than, I don't know, 42. I plus plus. Can't always do 10. That's boring. Okay, I'm going to generate a bunch of numbers. And then I'm going to do something here where I'm just going to print out the I. So I'm going to push it back in, and I'm just going to print out the thing. And so we can kind of see what's going on. I'm going to put a little space here. And then I'm going to put an end line at the end of this loop. Okay, so if I give this a run, you'll see that it made quite a lot of numbers, just enough to kind of fill up the screen here. Okay, and so I made a lot of numbers. I'm pretty happy about it. I made numbers from 1 to 100. They are integers. Cool. I push them back this way. Let's shorten this down a little bit so it's a little easier to see all the numbers that we have. And so we can, I'm going to tab stuff in to make it a little easier to read. Maybe I want to go in and right now, maybe I don't want to add in every like number. I only want to print out or I only want to print out like a certain combination of things. So let me do it this way. Instead of outing numList at spot I, I'm going to do roll. And this is going to print out all of the things. But I'm going to ask a question. I'm going to say if roll mod, which is the %, 2 equals 0, then I'm going to push it back. You might be like, what are you doing? What is that? Well, remember how we did a check to see if things were even and odd? So the little % is dividing by 2 and checking the remainder. So now I'm going to save off the roll. I'm going to print it out so we know what we got. And then if it's divisible by 2, then I'm going to add it to the list. Okay. And so then I'm going to copy my loop here real quick to make my life a little easier. I'm just going to print out this list again. You know what? I'm going to print out, I don't know. Let's go back to 42. And instead of going up here, I'm going to do numList dot size. And so, and it's little parentheses there. And let's switch this to J. And then we'll copy this, throw down some brackets, and then we'll have this be numList at spot J. Cool. So if I run this and all goes well, let's make it like 30, just so you can see it a little better. Okay, so you can see here I printed out the full list up here, and then here, look, this thing only has it only printed out these things, right? So the only things that got added to the list, and then I went back and added them, is that. Later on, we'll get into some other cool stuff we can do with these vectors, but this will get you started on the problem for right now. The problem for right now is something called meanie. Write a program that lets the user enter in as many numbers as they would like, one at a time. Find the mean of the numbers, then print out all of the numbers below the mean. This one's pretty similar to what we just did, so hopefully this won't take you the full 15 and you can get it square away. Let me pause. We'll come back in a minute. Okay, welcome back, folks. Hopefully you're feeling pretty good about this. I'm going to switch over to the screen, and I actually am using the default code from the demo here a little bit. Oops, I had the rolled in bones left over from when I adjusted that. And I'm not going to need any random number generator for this one, so I'm going to take all those out. I always like to be in the habit of, one, I like to reuse code that I've written because, that keeps me from having to type a lot of stuff, and, sometimes you forget exactly everything. But I also like to remove stuff, and, if I'm not going to have it there, the C++ style is sort of printed out. One thing I definitely know I'm going to do at the end is I'm definitely going to I'm going to be printing out all the numbers based on the end here. And so I'm going to switch a couple of things. One is I'm going to switch this over to a float of numbers. And I am definitely going to have to get the user number from somebody, because they're going to be typing in stuff over and over again. And the other float I'm going to have is I'm going to have the mean, because I'm going to have to calculate it all the way myself, and so I'm going to need to use that to have a sort of a final value. And to calculate the mean, I could just sort of do it all in one variable, but I think I'm going to have the total be something too. So then I can kind of keep a running total of all the numbers. I don't have to worry about it. And then the cout statement, I'm going to rehash this, but ultimately I know I'm just going to throw in one if statement in here, which is numList at spot j is, well, less than the mean. So if we get all the way down here, then you know what? Let's get our brackets lined up. This got it tabbed in. That can get tabbed in. And so I know I'm going to be printing out everything that's below the mean. Okay, great. Okay, so the next thing is that I'm going to have to ask for the person to enter things in. Okay, and we calculated the mean in one of our other programs, right? So we had something where we were basically doing a while thing, and we were asking questions about the user number, and then we're doing things based off of that. So I'm just gonna, first take on this. I'm gonna say, hey, while the user num is not equal to -1, because for whatever reason I'm gonna have them enter in positive numbers for finding the mean in this case. And so, okay, so while the enter is not equal to -1 is, what am I going to do? Well, I'm going to say cout, please enter the next number, -1 to quit. Okay, awesome. And then I'm going to cin user num. And then I'm going to say, well, you know what? Actually, I'm going to do something kind of different. Instead of doing this as while this is equal to -1, this is a little weird because I have to do some tests against it being -1 or not -1 before I do the average and stuff. So I'm going to do it in a little bit different way. I'm going to call this a while true loop, which just basically means I'm going to go on forever unless I get one of those break statements. And then I'm just going to ask right here, if user num equals -1, well, then I'm going to do the break command. Okay, I'm like done doing everything. And then I'm going to like skip out on this loop. And then I can go about my like math ways and stuff like that. If it's not -1, then no problem. You know what? Total plus equals user num. Okay, and well, num list dot pushback user num. So why am I doing it this way? Why am I pushing? I'm adding and pushing back the numbers. Well, the total, I basically don't want to have to go back through the list again and make up the total. I'm going through it here. Might as well add it to the thing. Pushback is going to add it to the list. And I don't need to keep track of how many numbers they enter because ultimately my list should tell me how many things are in it, right? The size of the list will tell me how many things. Fantastic. So I'm going to just do that. And then once I leave this, well, what's the mean going to be? The mean is going to be equal to total divided by num list dot size. Fantastic. And so, yeah. So hopefully you had a test case ready. Oops, what did I do? Oh, I spelled numList. A little bit things. You'll notice that I make it, I always do the lowercase first word and then I do capital here. That's called Camel Case. I think I mentioned that before. It makes it so I can tell these variables apart a lot easier, which is pretty handy. So I give that a run and then I'm going to enter in some numbers. And the thing is I'm going to sort of cheat a little bit. I'm going to enter a bunch of small numbers and then I'm going to enter in a really huge number and hopefully it'll print out every number but the huge number, right? So I'll be like 3, 5, 7, 2, 1, 88, -1. Okay, awesome. So look, it printed out 3, 5, 2, 7, -1. So that feels good, like it, did that. I should probably make sure that I didn't accidentally do it on the thing, the last thing of the list. So I'll do 88, 3, 5, 1, 6, 3, -1. And hey, look, printed out the numbers I expected. So I feel pretty good. Okay, awesome. And then you know what? I should probably print out what the mean is. So I know that what I'm doing, see out, the mean is, and then we'll print out that mean. Okay, awesome. So now I can do like, type in a few numbers. Got the mean is 10, and there are the numbers below it. And hey, it looks pretty good. So overall, pretty happy with this cute little program. And that is it for right now. Cheers.